Hey guys, today in my this video, I'm going to talk about different terms, some terms, and I'm going to talk about time to failure, mission failure. And let's have a look what I'm going to discuss in my this video, what we have, and we are also going to discuss something about power law relationship and the time to failure, mission failures, and we have different costs. What are those costs? Okay, now we have some terms. I'm going to discuss about these terms. Let's have a look. We have a capex cost. What is a capex cost? It is the capital cost or capital expenditure that is being spent to purchase an asset. The starting money being invested in a business for the long term profit of that business. Asset. You know what an asset is? An asset is anything that we buy, that the money we invest in a business for long term profit, so that we can get a long term profit, that one time we have invested our money in that business and we are now having going to have a long term profit. That is our asset. So what is the capital cost? Capital cost is basically that money that is being spent to purchase that asset. Suppose you have a suppose you are in a, what we say, in a real estate business. Okay, suppose you are in the real estate business and you see a house and you purchase that house. So that is the starting money, that is the money, starting money that you spent to purchase that house. Okay, starting money. So that money is the capex cost. So just to start our business, and for the long term investment, we are doing long term investment, we would be having long term profit. Okay, that's how that house is going to give us a long term profit. So that's why we are purchasing that house. So the money that we spend on that asset, on that house, is our capex cost. Just to purchase that house is our capex cost. It is our capital cost or capital expenditure. And now what we have? Opex. See, OPEX. Opex cost. What we have? Opex cost. It is the operating cost, the money that is being spent on the repairs or maintenance day by day on our business. Suppose we got a business, we start a business, and the business, first we spend money, we purchase that business, we have a product, or I gave you the example of a house. We have a house and we purchase that house. So the starting money that we spent on that house was the capex cost. Now the maintenance or the repairs, that suppose that house is not a good one and we have to just to get a more and more profit, we have to invest in that house so that it gives us more and more profit. So that's why we are spending on its repairs and on its maintenance, and we are making it more beautiful and more, wealth coming, so that we have a more wealth to come. So that cost that we are spending day by day and daily, that we are spending in days to that house, is our opex cost. Okay, so that is the operating cost, just to increase our profit. And now we have the life cycle cost. What is the life cycle cost? This is defined as the total cost that is being spent on our product or business from starting to end on its overall life cycle. So we have a business and we bought a house. We are in the real estate business in which we bought a house, and we first do the purchase the house, that was our capex cost, and then we do day by day maintenance and repairing of that house, that was our opex cost. And the overall total cost that is being spent from start to business to end of for that business, the overall cost is our life cycle cost that we have spent on our business, the total overall cost. Okay, including the capex cost, the opex cost, the sum of both. So that is our the cycle cost, life cycle cost. Okay, this is the overall cost. Now we have contribution margin. What is our contribution margin? This is the subtraction of the associated available cost of a product or item from the overall revenue generated from that product. This is the profit that a single component has given. What it means, I know you must not get it from reading the definition. Okay, I explained you. Contribution margin is basically, this is that we have a revenue. Okay, we bought a product. Suppose we bought a product and we sell it. Okay, so the revenue generated from that product, the overall revenue generated from that product, okay, minus the associated available cost of the product. So minus the purchasing price of that product. We have the revenue minus the purchasing the purchasing price of that product. So we have to minus the purchasing price of that product from the revenue that is generated. So this is basically we have to find that how much that product gives the profit. Okay, how much the profit is gained by that single product. So how to find the profit? How we find the profit? We see that how much that product cost us. Okay, we minus its cost, yeah, its purchasing cost from the overall revenue generated of that product. So we minus the purchasing cost of that product. So what we get? We got the profit. We got the profit of the money that product has given us, that single product or single item has given us. So that profit is called is our contribution margin. Got it? RTS, ready to serve service. What is ready to serve service? This is the payback to produce on immediately. RTS. So this is basically, suppose we have some business or we have some selling and purchasing in which we got an RTS. We got an RTS, which is that we say that this business is ready to serve business, means that it would be we have a payback, like we invest and we got immediately. So that would like we invest and we got immediately the profit. So that is our ready to serve service. Okay, and what is LTS? Long term service, payback to produce on later. So suppose our house, we are in the real estate business and we purchase a house, and that is that would come in the LTS column, because that is long term service. That is the house is going to profit us from the long term, till the long term, because we have to put it till long term. We have to put a long period of time, keep it, so that we can be able to gain a lot profit. And so that's why we call it payback. Oh sorry, that was my battery error. So that's why we can say that we can have it, we can get the payback to produce later. We get the profit later, and in ready to serve service we get the payback immediately, like we get the profit immediately. So this is the difference between RTS and LTS. And now we have TF, that is time to failure, mission failure. Okay, TF, you know, everybody knows time to failure, it is the mission failure. Okay, and we say we have a law, a relationship, that is the power law relationship. In this video I have discussed some topics. Okay, and in this video I am going to discuss power law relationship and the time to failure, mission failure. Okay, and I'm going to drive time to failure of this power law relationship. So let's have a look. We have, for power law relationship, we have a formula S equals to S0 1 plus A0 T at the M. Okay, so this is the formula for power law relationship, and this can be, and it is in the form of positive and it is also in the form of negative. So what we got, S equals to S0 1 plus minus A0 T at the M and bracket close. So this is plus minus, we get in the form of plus minus. So this is the formula for this power law relationship, and how we can drive our time to failure from this power law relationship, from these formulas. How can we derive our time to failure? Let's have a look. This equation can be represented in the form of this also. Here we find Tm. We have to find our Tf, time to failure. So we bring Tm out, and what we got? We multiply this S1 into S0 into 1. So S0 plus S0, A0 here comes here, and Tm remains here, and these goes in division, and they are in the form of S minus S0 over S0 over A0. I hope it is clear. It is simple multiplication division and nothing else. And the same happens with this equation. Okay, S equals to S0 minus this multiplies S0 multiplies by A0, and this one S0 multiplies by 1, so S0 comes here, and again this Tm is being represented in the form of this. So we have got two equations for Tm. One is this one, and one is in the positive one, and one is for the negative one. Okay, and what we say now? We say now our T is equal to Tf. T is our time to failure. We are going to find out time to failure. So we have Tm equals to, what we do now, we bring this A outside, this A0 outside, and inside this remains here. Okay, S minus S0 over S0. This remains inside, and we bring this A0 outside, and in the form of plus minus, this is in the form of plus minus, so we bring it outside, and this remains in, and this is here. And what we have to do, we have to find, we say that our T is equal to Tf, time to failure. So that's why this M goes the other side of the equation. So when it goes the other side of the equation, it comes 1 over M. It becomes 1 over M, and T equals to 1 over plus minus A0 S minus S0 over S0. So this is our final T that comes, and we have Tf equals to, we say that our T is equals to Tf, so this can be written also in the form of Tf, that is 1 over plus minus A0 S minus S0 over S0, and we say we can write it in the form of critical. Okay, this was our T was this thing, and when we convert it into T into Tf, we say this T is equal to Tf, we wrote it as critical. Okay, we say this thing as critical, and rest remains the same. Okay, and we also say we have a formula of V threshold equals to VTH0 1 minus A0 T at the M. So we have this formula of V threshold, and some values are given. We have some values. It's just that this is the procedure of finding time to failure. So we have V threshold 0 as 0.75, maximum VTH we say it as 20%. We say M, we consider M as, we take M as 0.25, A0 as 1, and we also say that A0 equals to this equation. We find a value for A0. We have found a value for A0. So A0, how it can be found? It can be it can come in the form of this A0 can go there, A0 can go there, and this T can come here. So it's just, this is written, A goes there and T comes here, so it is 1 over T. This equation is being represented in the form of this. And what we say this, that our S minus S0 over S0 is equal to 0.03, 1 over time is 1 over hours, time is hours, so 1 over hours. So this equation we considered, or we assumed A0 as 0.03, 1 over hours. Got it? And now what we do, we put the values for V threshold in our put all these values in our V threshold. So for V threshold 0, we got 0.75, 1 minus, and in the place of A0 we write 0.03, 1 over H, and T remains T here, and for M we write 0.25, bracket close. Now we are going to do for TF. Now what we say for TF, we are talking about V threshold. So we say for TF we have a formula, time to failure, we have a formula in the form of V threshold, that is 1 over A0, V threshold 0 minus V threshold over V threshold 0, and bracket close, critical, and whole bracket is 1 over m. So this is our time to failure. When we have V threshold, we can write the time to failure in this way. So what we got now, we replace the values. We just replace the values 1 over AO, that is 1 over A0, that is 0.03 over R's. You remember here it comes here, V threshold remains here, and minus 0.8 V threshold 0 over V threshold 0. How this 0.8 comes? Because we say that we have V threshold, maximum V threshold is 20%. So when we have maximum 20%, so 20% is equal to 0.2. So we write V threshold equals to 1 minus 0.2. So this becomes 0.8 V threshold 0. So we minus this maximum, because we don't need the maximum V threshold. Okay, we have given the maximum V threshold, so that's why we have minus this V threshold, maximum V threshold from 1, and when we minus this, we got 0.8 V threshold 0. So that's why we have written it in the form of here. We wrote V threshold in the replacement of V threshold. We write 0.8 V threshold 0 over V threshold 0, and this is critical, and bracket close, and 1 over m becomes 1 over 25. Okay, and what happens? This is 1 minus 0.8 becomes 0.2, and V threshold cancels V threshold, and bracket close, and 1 over 0.25 becomes 4. They got divided, so it becomes 4. And what happens? 0.2, what remains? 0.2 over 0.03 over R's at the 4. This remains, and when you will do it with calculator, 0.2 divided by 0.03 over 4, when you will do it with calculator, you will get a value 1975.30 R's, and this R's remains here. So we have got, and we are finding time to failure, so that's why it would be 1975.30 R's. It would be represented in R's. So that was for time to failure. Now we are going to find what we are going to find? CTF, that is cycle to failure. Yeah, cycle to failure. Okay, so we have CS is present here, that is the size of crack. CTF is the cycle to failure, and we have number of cycles here present here. Okay, and what this CS is? This CS can be represented in the form of this equation: CS0 1 plus A0 and cycle over m. So this CS can be represented in the form of this equation, and we have the values for CS0 is 1 micrometer, A0 is 10 at the minus 6 over cycles whole cube. Okay, this is A0, and we have m equals to 3. Yeah, clear? So we just put the values in the place of CS0. We write here 1 micrometer, 1 plus in the place of A0 we write 10 at the minus 6 cycle cube here, and n cycles remain as it is, and in the place of m we write 3 here. Okay, so how this CS, size of crack, can be represented in the form of cycle to failure? You remember, we represent V threshold in the V threshold can be represented when if we say that time to failure, so V threshold can be represented in the form of like this. The time to failure becomes this, and for size of crack, the cycle to failure becomes like this. What it is? It is 1 over A0 CS minus CS0 over CS0. So this CTF, cycle to failure, becomes like this, critical over 1 over m. So now we can easily put the values, and we are saying that our CS is equal to 500 CS0. We are considering this value. Yeah. So for CTF, our we can represent our CTF in the form of CS like this. Okay, so we replace the values. A0 becomes 1 over 10 at the minus 6 cycle at the cube, and we have this CS, we say it's 500 CS0, so it comes here minus CS0, CS over CS0, and bracket close, this is critical, and whole 1 over 3. So 500 CS0 minus CS0 becomes 499 CS0, and these both cancels out, and rest remains the same. critical 1 over 3, and 499 over 10 to the minus 10 to the power minus 6 cycle cube. This remains here. Yeah, this thing remains, so it is represented like this, and 1 over 3 becomes here. And when you will calculate it, and when you will going to do it with the calculator, so 499 divided by 10 is to the power minus 6 whole 1 over 3. Yeah, at the 1 over 3. So when you will do it with the calculator, you will get a value 793 cycles. So our cycle to failure is 793 cycles when we have these values and these equations are given. When we have these values, we put these values and we got 793 cycles. So this was our cycle to failure, and we have a formula which says that when we have an electromechanical system, what we have the formula, this time to failure becomes, what it becomes, TF equals to 1 over plus minus A0 V comma R comma T, S minus S0 over S0 whole critical bracket close 1 over M. So when we have an electromechanical system, our time to failure is represented in the form of like this. Okay, and that was all for the time to failure and cycle to failure. That was all for this